Hi everyone, welcome back to the channel, and today on solve Leetcode daily challenge problem number 2971. Find polygon with the largest perimeter. So we'll first check out the problem statement. It is tagged as a medium problem and it's an interesting problem to solve as well. And after that we'll check out the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that we'll get an array of positive integers num of length n. Okay, and we have to basically find out the maximum largest possible parameter of a polygon. Okay, so they have also defined what a polygon is. A polygon is a closed panel figure that has at least three sides. Okay, the longest side of polygon is smaller than the sum of its other side. So it has at least three sides, and longest side will be smaller than the sum of its other sides. Okay, so conversely, if you have, for example, if you have k equals to k greater than or equals to 3, then we'll have all these numbers, and the notations can be a1 will be smaller than equal to a2. So smaller than equal to is is what we should point at, and the other condition is the longest side of polygon is smaller than the sum of all other sides. So a of k is less than sum of all other sides. Okay, then there always exists a polygon. Okay, the perimeter of polygon is perimeter of any shape is basically just summing up all its sides. So this is what they have defined, and we have to return the largest possible perimeter of a polygon whose side can be formed from nums, or -1 if it is not possible to create a polygon. Okay, so let's check out and let's just write down what we have in the question and what we are supposed to do. So starting with the given statements, we have sorry, just a sec. Yeah, so we have to make polygons. So polygons. Okay, and of course, like our sides will be greater than or equal to 3, because you cannot make a polygon with two edges, two sides, right? Because it won't be a closed curve. So that's why it will be greater than equal to 3. And the important properties are, for example, we have three sides, then a of 1 will be greater than equal to a of 2, greater than equal to a of 3, and so on and so forth. And other property was a1 plus a2 will be greater than a3, and this will be followed on with any number of n's. So to solve this problem, what I'm going to do, I'm going to sort the given array, and we will use prefix sum approach to get the answer. Okay, so to do that, what we will be doing now, for example, I have taken the same example from the problem statement, and when you sort this, you basically get what? 1 1 2 3 5 12 50. Let me just check if I have covered all the numbers around 1 2 3 4 5 6 7 1 2 3 4 5 6 7. Yeah, so this is what we have done. We have sorted all the elements out. Okay, now let's say my total till any index is, let's keep it in a variable. Let's name it total. Okay, and I'll initialize it with 0, and let's initialize result, which will return at the end with -1, because this was the result which was expected if the parameter or polygon, if the polygon is not possible. So that's why let's initialize it with -1 itself. Okay, next what you'll have to do, just iterate this array and check if the total. Okay, so what we'll be doing for num in nums, in sorted nums I should say, num in nums, we will check if total is greater than num or not. So this basically maps to this condition. And one more thing, like by sorting we have already satisfied this condition. Okay, so now we are satisfying both the conditions, and if this condition gets satisfied, then of course what we will do, we will add result, we'll update the result with total plus num, because in total we have sum of all the other sides and num is the current, or n is the largest, num is the largest side. Okay, and in total we will just simply add num. Okay, so what we are doing over here, okay, so think of it as with each iteration, we are adding one edge in the polygon. For example, at 0th index we added one edge. Okay, we added one edge. Now with second iteration we added another edge. Okay, I'm just taking an example. Is it possible to form a polygon? No. Why? Okay, so let's say total as well. Let's do a dry run. Now total is 2, result is -1, and before getting the second element, before we get this element, what we will check, this was the answer basically. Okay, so we checked, is total greater than num is what, 1, and total is 1, so no. Then what we will do, we need not to process this, we need not to update the result, and we add in total. So now we have 2 edges and total is 2 now. Okay, it is 2. Okay, next is 2, right? Now can we have can this be a valid polygon as per the requirement? No, because the current side is 2, but our total is also 2, so this also not satisfies the condition, and our total now gets 4. Okay, next element. Okay, this seems possible. Why? Because 3 is greater than all these. Okay, all these values, and 3 is smaller than 4, right? So this forms a polygon. And now our total will be 7. Now our total is 7 by 4 plus 3, and we'll keep on checking the same condition with the elements, with the left out elements as well. So let's check out the code for the same. And yeah, so this is the code. I have already tried it. So what we are doing over here, we have sorted the array first, and as I explained, we have defined two variables, total and result. Total is initialized with 0 and result is initialized with -1. Okay, after that what we are doing, we are just simply simply iterating the array which we have, the sorted array which we have instead, I should say, and checking the condition. So by total, what we are doing, we are simply just keep on adding the edges in the polygon, and we are checking if the current element is greater than the total sum or not. So this basically satisfies both the conditions we had in the question. If both the condition are satisfied, then we are adding that or updating our result with the number. And no matter if this condition gets true or not, we will keep on adding the edges to the polygon, right? So total basically represents your length of edges, and you keep on adding the edges and it will increment it as well. And at the end, we are just simply returning the result. So let's check out the test cases. I'll run it again. So as you can see, the test cases got clear. Let's submit for further evaluation. Okay, it is taking some time. Yeah, so this is it. As you can see, the test case got clear, and I would say we have performed decent enough. So yeah, thanks again guys for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.